Japan quietly fired a weapon that rewrites naval warfare. No explosions, no missiles, just raw physics moving faster than the world was ready for. One, the shot that made militaries go silent. Japan's railgun test wasn't flashy, but it was historic. A ship-mounted electromagnetic cannon fired a solid projectile at hypersonic speed and actually hit a target vessel in open ocean. No lab setup, no trailers, a real warship, real sea conditions, real accuracy. This single test shattered the belief that railguns were just science experiments. For years, experts said the tech was impractical at sea. Japan proved otherwise in one clean firing sequence. The projectile didn't rely on explosives, it relied on speed. At Mach 6.5, the kinetic energy alone was enough to punch through steel. No guidance smoke, no heat plume, just a silent strike that arrives before defenses can even react. That's what shocked analysts. Not theory, execution. What makes this moment unsettling is the simplicity. No explosion, no dramatic flash, just a clean launch and a silent exit. That's the point. This weapon isn't designed to scare visually. It's designed to arrive too fast to stop. Militaries watching this footage didn't see a test. They saw a future engagement timeline collapsing in real time. 2. Mach 6.5. Why interception becomes almost impossible. At nearly 7 times the speed of sound, Japan's railgun projectile enters a zone where traditional missile defense struggles. Radar tracking becomes compressed. Reaction windows shrink to seconds. Interceptors that rely on prediction suddenly fall behind reality. This isn't just fast, this is defense-breaking velocity. Unlike missiles, the railgun round emits no heat signature. That means infrared seekers are useless. There's nothing to jam, no signal to spoof, and no engine to shut down. The projectile is just metal and momentum. Even advanced air defenses weren't designed for this kind of threat density. That's why militaries reacted so strongly. Speed plus simplicity equals reliability, and reliability in combat changes doctrine overnight. When speed reaches this level, defense systems stop behaving normally. Operators don't get multiple chances. Software doesn't get time to correct. Everything compresses into a single decision window. That's why Mach 6.5 matters. Not because it sounds impressive, but because it removes human reaction from the equation almost entirely. Physics takes control, and physics doesn't negotiate. 3. The naval bullseye that the US never achieved.
Mounted electromagnetic railgun, but actually hitting a target ship. This is the Japanese Maritime Self-Defense Force test ship Asuka, and these images, released by the Japanese Defense Ministry, show the test weapon and the target struck.
The United States spent over $500 million on railgun research and still walked away. Barrel erosion, power demands, reliability failures. The program died quietly in 2021. Japan watched all of it, learned from it, and fixed the weaknesses. In 2023, Japan mounted its railgun on a test ship and fired at a real target vessel in the Pacific, roughly 300 kilometers south of Tokyo. The projectile hit cleanly. That moment mattered because it crossed the line from experiment to weapon. This wasn't a test range illusion. It was ocean, motion, salt air, and live targeting. Exactly where previous programs failed. This hit carried more weight than any press release ever could. Hitting a target ship in open ocean proves stability, tracking, and timing all worked together. That's where previous programs failed. Salt air, ship movement, power fluctuation, all real-world problems. Japan didn't avoid them, it solved them. And that's why this test instantly changed how serious analysts took the railgun again. 4. Power problems that Japan solved quietly. Railguns fail when power systems overwhelm the ship. Earlier designs needed the output of a small power plant for a single shot. Japan changed the approach. Instead of forcing the ship to supply everything, they used containerized capacitor systems. Stored energy, controlled release, faster recharge. The result? Over 120 consecutive shots without catastrophic rail damage. That number stunned engineers. Rail wear was the biggest killer of earlier programs. Japan crossed that barrier without press conferences or hype. This is why the weapon suddenly looks deployable. Not someday, not theoretically, but realistically within the next decade. Power was always the railgun killer. Japan didn't brute force it. They redesigned the flow. By storing energy first and releasing it precisely, the ship stays stable and the weapon stays alive. That's why 120 consecutive shots matters more than raw speed. It proves endurance. Endurance is what turns a weapon from a demo into something commanders can actually rely on. 5. Why this railgun terrifies missile-based navies.
Adversary extremely difficult. Those speeds, combined with specially designed shells, gives highly effective penetrative power. And increased range and power means increased standoff capability.
A single railgun round costs tens of thousands of dollars. A modern anti-ship missile costs millions. That math alone changes naval warfare. Even if interception rates aren't perfect, the exchange ratio favors the railgun operator every time. Missiles can be jammed, spoofed, shot down. Railgun slugs cannot. They don't explode. They don't broadcast. They just arrive with devastating kinetic force. Against drones, cruise missiles, and even hypersonic threats, this creates a layered defense nightmare for attackers. That's why this test echoed far beyond Japan. It wasn't just a weapon firing, it was a doctrine collapse moment. Once cost flips, strategy follows. Expensive missiles stop being intimidating when cheap interceptors exist. That's the nightmare scenario for missile-based navies. You can still fire first, but you'll lose financially even if you succeed tactically. Railguns don't just stop threats, they punish the economics behind those threats. And that's how doctrines quietly collapse without a single battle being fought. 6. China's laser army versus Japan's steel slug reality.
A projectile leaves the barrel at Mach 6.5, faster than any missile can blink. Across the sea, a turreted laser cuts the air with silent light, shown off at Beijing's massive parade marking the 80-year anniversary of victory over Japan.
China proudly unveiled its LY-1 high-energy laser system, claiming infinite magazine depth and near-zero cost per shot. On paper, lasers sound unbeatable. In reality, physics disagrees. Fog, salt spray, humidity, turbulence, lasers lose power fast at sea. Sustained dwell time is fragile, especially against supersonic threats. Japan's railgun doesn't care about weather. A Mach 6.5 slug ignores jamming, ignores haze, ignores propaganda. It doesn't need to burn through targets. It punches through them. That contrast is what makes analysts uneasy. China sells beams of light. Japan delivers holes in steel. Lasers look clean and futuristic, but the ocean is unforgiving. Moisture, spray, and turbulence don't care about theory. Railguns embrace that environment instead of fighting it. Steel doesn't scatter. Momentum doesn't fade in fog. That's why this comparison matters. It's not about which technology sounds advanced. It's about which one still works when conditions turn hostile and imperfect. 7. The cost war China cannot win long-term.
Against cruise missiles, drones, or even hypersonic threats, that's a cost exchange Beijing can't win. China spends $10 to $15 million on a DF-17 or DF-26 missile. Japan spends $25,000 on a railgun shot that can swat it out of the sky. That's budget math no Politburo accountant wants to explain. And Tokyo isn't going alone.
Here's the brutal math. China fires a DF series missile costing $10 to $15 million. Japan answers with a railgun shot costing roughly $25,000. Even if interception isn't perfect, the exchange rate is devastating for the attacker. Defense finally becomes cheaper than offense. This flips decades of naval economics. Missile saturation attacks were designed to overwhelm defenses financially. Railguns break that logic. Suddenly, attackers bleed money faster than defenders. That alone forces strategic rethink across the Pacific. Wars aren't just fought with weapons, they're fought with budgets. When defense becomes cheaper than attack, escalation slows down. That's what scares planners the most. A system that drains your stockpile faster than the enemy's patience. Railguns introduce that imbalance, not through dominance, but through sustainability. And in long conflicts, sustainability decides everything long before victory does. 8. Why the United States is quietly watching Japan. Now,
compared with a conventional gunpowder version. So why is developing an operational version taking so long? Well, one reason is the huge amount of electrical power needed. Military prototypes like the US version seen here being tested in 2017 needed tens of megawatts for a single shot.
The irony is hard to miss. The US pioneered railgun tech, spent $500 million proving it worked, then abandoned it. Japan picked up the blueprint, solved the core issues, and moved forward. Now, American defense circles are watching Tokyo's progress closely. Japan has already opened joint development paths with France and Germany, and US contractors have been invited back into the ecosystem. The weapon America shelved might return, not as an American project, but as a Japanese-led one. This is the uncomfortable part for Washington. The technology wasn't flawed. The commitment was. Japan showed that patience beats hype. Now the US faces a choice: rejoin from the sidelines or watch allies deploy systems it once pioneered. Either way, the center of gravity has shifted. Innovation didn't stop. It simply changed flags while no one was looking. 9. From test ship to future destroyers.
And Japan is thinking bigger. ATLA already mapped a roadmap to 20 megajoule guns, quadrupling the muzzle energy. Their presentations have shown railguns sketched onto future 13 DDX destroyers, the next generation fleet expected in the 2030s, and even Maya-class Aegis destroyers. What America abandoned as impractical, Japan is planning to deploy as operational naval hardware.
Japan isn't stopping at experiments. Defense roadmaps already show railguns sketched onto next-generation destroyers planned for the 2030s. The goal is scaling from 5 megajoules to 20 megajoule class weapons, quadrupling impact energy and effective range. This isn't a prototype path, it's a deployment path. Containerized power, modular capacitors, and improved rail durability make integration realistic. Once installed, railguns become permanent fixtures, not demo pieces. That's when balance truly shifts. Once railguns move from test ships to frontline destroyers, their presence alone alters engagement planning. Enemies must assume interception even before firing. That hesitation is deterrence, not through fear, but through uncertainty. Future fleets won't just carry missiles and radars. They'll carry kinetic answers that don't blink, don't jam, and don't ask for permission from the weather. 10. The shot that echoes across the Pacific.
The railgun isn't a silver bullet, but it's the kind of deterrent that says, fire your $1 million toys, we'll kill them for the price of a Honda Civic. This is why the railgun isn't dead. It just moved zip code. Washington called it a YouTube experiment.
This railgun test wasn't about destruction, it was about messaging. China parades lasers. Japan fires steel at hypersonic speed into real targets. One shows capability, the other proves it. In modern deterrence, proof matters more than promises. When the next conflict calculus is written, it won't be decided only by missiles or jets. It will be decided by who can intercept cheaply, reliably, and at scale. Japan just showed it belongs in that future, and it did it without saying a word. History remembers moments, not announcements. This firing will be remembered because it proved something quietly, that advanced warfare doesn't always arrive with noise. Sometimes it arrives silently, too fast to stop, and leaves everyone recalculating afterward. Japan didn't declare dominance. It demonstrated capability, and in modern deterrence, demonstration always speaks louder than intent. Japan didn't just test a weapon, it sent a signal. Silent, fast, and impossible to ignore. If you want more real breakdowns like this, hit subscribe, drop a like, and share this video. Because the next shift in global power won't be loud. It'll be faster than sound.